Okay. So last week we have seen about proc print and proc sort. We will refresh for 5 minutes and then we will discuss about the new topic. So last week we have seen about the procedure. Uh, we have seen proc print. So in proc print, the syntax is the key. It starts with the keyword proc, and then the procedure name print, and then data equal to means what is the input file you want to give, what is the data you want to print. So we have already created one data set called clinical demo. We are going to print this data set. So the syntax is proc print data equal to clinical demo. Okay, the title is not required. So this will print the data in the so okay, I have to run the data set first. Okay. So using the proc print, you can print the data in result tab. Okay, so and additionally, you can use additionally, you can in proc print, you can use the var statement, var. So in var statement, you can choose particular column name. If you want to display only this four columns, you can mention the column name after var. So this proc print will display only this four columns. Similarly, so when you are using proc print, there will be one variable called observation. By default, it will create. For first row, it will the observation number is 1, 2, 3, 4, 5. So if you don't want observation column and you want some other column name, so I will give patient ID instead of observation. If you want a patient ID as a first column, you can give it under the ID column. So this will replace the observation number as the first column. Okay. And then we have seen if you want to filter the data, if you want to filter down the data, only systolic blood pressure greater than 140, you can use a filter. You can use var also, you can use if condition also. It is based on your wish. So I'm using var here. So wherever the observation is, the blood pressure is greater than 140, uh, it will display the data. Okay, so there are two patient ID whose systolic blood pressure is greater than or equal to 140. Okay. So another one is we have seen a label statement. Okay. This one, let me. Okay, so this won't come under the procedure. This will create a labels for each variable. Okay, so that you can use it in the data step itself. So generally, okay, let me run this code. So if you click this patient ID, it will tell whether there is any label or not. Okay, so you can give some description here. So if you click SPB, it will tell what is the label name, systolic blood pressure. So in proc print, if you want to display that, you can use an option name called label. Okay. So we have seen one more thing, split. So whatever you are giving here, the column names will be splitted. Okay, there is one more thing, no observation. If you don't want to display the observation number 1, 2, 3, 4, you can use no obs. This will not display the column called observation. Okay, okay, this is something. Okay. Okay, there is some issue in the code. Generally, if you want to split the column names, you can give it, for example, if you want to split the column names, you can use this option split equal to whatever symbol you are giving, it will split the column names. Okay. And then there is one more thing for column. If you want to calculate the sum total, then you can use proc print. And then in second line, you can use the sum statement. For whichever variable you want to calculate the total, you can give that variable name here. Okay. Okay, so it will calculate the total for that particular column. Okay. So another thing, if you want to display only first three observation, you can use after data equal to the input file name, you can open the bracket and give observation OBS equal to 3. That means it will display first three rows. If you want to display first four rows, you can give OBS equal to 4. Okay, so here we are using multiple option. One is label and another is var statement, and then we are using var statement also. We are filtering the data, and then we are calculating weight for the variable. So you can use the multiple options in multiple options, multiple statement in the proc editor. So this is the first procedure we saw. Okay, we have crossed already 15 minutes, so I will go a little faster. Okay. Then we have seen proc sort. If you want to arrange the data in ascending or descending order, you can use proc sort. Okay, so we have the data here. Patient ID, first the patient ID is 05 and next is 01. It is not in ascending order or descending order. The data is given randomly. If you want to arrange the data, then what you have to give is give proc sort and then the input data set name, and then by statement you can give the. So in by statement, you can give the patient ID. In patient ID, if you give by in by statement whatever variable you are giving, that variable will be sorted. Okay, in ascending order. Now, if you see the patient ID is arranged in the ascending order. Okay, if you want to sort it by descending order after by, you can give descending. This will sorry. So this will arrange the data in descending order 05040302. Okay. So you can arrange the data in either ascending order or descending order. Okay. So generally, proc sort, when you are giving this data, it will not store it in any location. Okay. If you want to arrange the sorted data, then you can use out option. The after data, you can use one option called out. Then you can give the whatever name you want. You can give it. The output will be stored in the name of sorted demo. Okay. So using out option, you can store the data, sorted data. Okay. Okay. So we have seen descending also, and also you can sort the data by multiple variable. We are sorting the data first by treatment, and then by sex, and then by age. We will see how it's sorted down. So first it will sort the treatment first A and then second B, and after that in treatment A, it will sort down by female and male, first female and then male. Similarly in treatment B, first with female and then male. Okay. And then age also in treatment A, okay, it will sort the data in ascending order. 35, 55, and then male. Okay. So it will sort it in the order of first treatment and then sex and then age. Okay. So there is something called when you are having a duplicate. Okay. For example, in our data, there is a duplicate patient ID 001. The data is occurring twice. Okay. So that time when you are sorting the data, the both the rows will come. But when you are giving no duplicate key, okay, the it will remove the duplicates. Okay, but it will check only in the column patient ID. So when you are using no dupe key, it will remove the duplicates in your data. So, but whatever column name you are giving in the page by statement, it will consider only that column. Okay, for duplicates, it will not check in age or gender and all. Okay. Okay, so there is one more option called no duplicate records. What it will do is it will check whether the year patient one is there, right? Year 45 male and it is treatment A. Similarly, the second patient, second row also similar. Okay, so but here, for example, here if you mention treatment B, okay, then the row became different. Okay, first row became different and second row became different. So when you are using no duplicate records, it will check the entire record, not only one column. It will check entire column, and if there is any duplicate, it will remove. But here, if you see, since the here the final column value is different, still it will consider as a different row. It will not remove the data. Okay, I think we will move to next one, new topic. So, okay. So generally, this is one of the important procedure in pharma company. So when you have a data, let me open one clinical trial dummy data. Okay, I'm opening on dummy data. It is COVID mortality data. Okay, so here if you see here we have the country-wise data and how many COVID cases and how many COVID deaths and how many recovered, how many active cases, how many total tests, and how many population. So here if you see there are a lot of numerical variables are there, total cases, and then one categorical variable is there. Okay, so when you have a numerical data, if you want to do some analysis, you can use the procedure called proc means. Okay. Uh, so proc mean everyone know it is average. Okay, means average. So using this proc means you can analyze the data. Okay. So in clinical trial or pharma company, they mostly use this procedure proc means. Okay. So here we have a data, patient ID, site, clinical trial site, age, sex, treatment, weight, systolic blood pressure, diastolic blood pressure, cholesterol. So we have nearly 9 columns there. Yeah, 9 columns are there. And what we are going to do is we are going to analyze this data. Okay. So in general, when you are using proc mean, okay, and then if you simply give data equal to clinical demo, okay, very simple code, proc means, and then data equal to clinical demo, this data set, and then run statement. This will give statistics, okay, for each numerical variable. So in our data, there are several numerical variable, like patient ID is a character categorical variable. Site is also a character variable. But age is a numerical variable. Weight is a numerical variable. Systolic, diastolic is a numerical variable, and cholesterol is a numerical variable. So for those numerical variable, it will calculate mean, median, standard. Sorry, it will calculate mean, standard deviation, minimum, and maximum. Okay. Uh, okay. So for age, what is the average age? It is 48.8. The average age is 48.8. Standard deviation means 8.6. Minimum means 35. Minimum age is 35 in this clinical trial, and maximum age is 60. Okay. So there are 6 observation in our data. Similarly, average rate is 75, standard deviation is 7.17. Okay. You may be thinking what is standard deviation. Let me explain what is standard deviation. Okay. So I have one data called blood pressure. I have a data for 6 subjects. Okay. For all the 6 subjects, the blood pressure is 140. Okay. So if there is all the data is 140, our mean is also 140. Okay. You can check, you can calculate. So if all the data is 140, then our mean is also then standard deviation means how much deviation from mean. Okay. Uh, how much our data points deviated from average or mean. That means we have to take first one and first data point 140, and we have to see how much it is deviated from the mean value. Mean is also 140 plus the second data point is also 140 minus 140. Okay, so you have to do for all the 6 observation like this. Okay, So standard deviation means how much our data points deviated from mean. Okay. Suppose if there are some different data, okay, then what we will do is if you have data like this, then our mean will be something like 145. Okay. Then what we will do, we will put 160 our data points and then average is 145. Okay. And second data minus 145. Okay. Similarly, we have to do for each data point minus the average value. Okay. So standard deviation means what is the spread or what is the deviation from the average value. Okay. If it is all the data points are same, then we will get standard deviation 0. But there is some deviation from average, there will be some standard deviation. Okay. So in age, the standard deviation is 8.6. Okay, and weight standard deviation is 7.17. The maximum weight is 65, minimum weight is 65, maximum weight is 85. Okay, so what this proc mean will do is, for all the numerical variable in your data, it will calculate uh, mean, standard deviation, minimum, maximum. Okay, by default, it will calculate for all the numerical variable in the data set. Okay, so pharma company, if they want to know what is the average weight, average blood pressure, they will use this procedure. Okay, and then here also you can use the var statement. If you want to calculate mean, standard deviation, minimum, maximum only for this two variable, age and date, then what you can do is you can in var statement you can give age, weight. Okay. So what it will do, it will calculate mean, standard deviation, minimum, maximum only for these two variables. Okay. So whatever you are giving in var statement, the statistics will be calculated only for this variable. Okay. But so generally there are so many statistics, okay. But here you are not able to see what is the median is, what is the mode is, okay. By default, it will give only four statistics, four measures. If you want to display more measures, there is one option, okay. So give proc means and data equal to input data set, and then whatever measure you want, you give it as an option. Okay. So after space, you type mean, it will come it as a drop down. Okay. And then median. Okay. And standard deviation, var and minimum maximum sum. I think mode you can't calculate. Mode you have to do different way. I will come to that point later. But if you want to calculate variance, median, and all, you can use it as an option. Okay. So here you can see mean, median, standard. If you want additional measures, you can put it in the proc mean statement as an option. Suppose I am putting only standard deviation and variance, it will display only two. Okay. So using this option, you can display whatever statistics you want. You can display that. Okay. So there is one option called decimal, controlling the decimal. Okay. Uh, okay. Uh, so if you see here, there is one decimal, right? 7.176. Here also one decimal, 10.400. How many numbers you want to display after the decimal? Okay. Here we are giving maximum decimal equal to 1. That means after decimal, it will display only one number. Okay. If you give 2, maximum decimal equal to 2, what it will do after decimal, it will display two numbers. Okay. So using maximum decimal, you can control the decimals and all. Okay. Now, okay. So for this, if you want to understand, for example, if there is any missing data, okay, it will tell in weight column how many missing data is there, and in systolic blood pressure how many missing data is there, and diastolic how many missing data. Missing data means I will explain. Okay, for patient ID, I'm keeping the data as a blank. Okay, for the patient ID 6, I'm keeping the cholesterol value as a blank. Okay. Similarly, I'm keeping the data. Okay. So there is one missing data in our data set for cholesterol value for patient 6. Mm. So I'm adding cholesterol as one of the variable. One minute. Okay. Okay, I think we have to change the format of the input data set. So what I'm trying to tell is if there is any missing data in our data, uh, and then if you are giving the NMIS option, what it will do, it will tell how many missing data is there. If you use N, it will tell how many observations or how many rows are there in the data. Okay. So now there is one more thing in proc mean there is something called class statement. Okay. So what this class statement will do? If let me open the data. Okay, so here we have 6 patients and 3 patients got treatment A and 3 patients got treatment B. Okay, I want to know for treatment A what is the average systolic blood pressure and what is the treatment B, what is the average systolic blood pressure. By that, we will know whether treatment A works better or whether treatment B works better. Okay, so for categorical variable, we are calculating the average value. For treatment A, what is the average systolic blood pressure? And for treatment B, what is the average blood pressure? Okay. So what you have to do, the whatever categorical variable you want to calculate the average, use that variable here, and what are all the average you want to calculate. Okay, I will keep only systolic blood pressure. Okay. So what this will do, it for treatment A and B, it will calculate average systolic blood pressure. It will calculate mean, median, and standard deviation. Okay. So here, if you see for treatment A, average blood pressure is 128. For treatment B, average blood pressure is 144. So here, if you see, for treatment A, somewhat the blood pressure is looking normal. Okay, than treatment B, we can consider the treatment A may works better than treatment B. Okay, this is just a dummy data. So using this, we can see what is the average between treatment A and treatment B. Similarly, if you want to calculate the diastolic blood pressure also, you can check. Okay. So diastolic also, treatment A it is less, and treatment B it is 92, treatment A it is 84. Okay. And also you can do one more thing. You can use multiple categorical variable in treatment A. In male, what is the average blood pressure? In treatment A, for male, what is the average systolic blood pressure? So in treatment B, for male, what is the average blood pressure? So for two categorical variable also you can use. Okay. So here, as I mentioned, in treatment A, there are two female. Okay, and their blood pressure is 75. Okay, their blood pressure is 127.500. In male, it is 130. Okay, so female has lesser systolic blood pressure than male systolic blood pressure. Okay, in for treatment A. Treatment B, if you see, the average blood pressure for female is 140. The average blood pressure for male is 146. Here also for female, the blood pressure is comparatively lesser than male. Okay. So like this, using class statement, you can calculate the average for the categories. You can use three variables also. Okay. 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 What we are going to do is using instead of class, you can use by statement also. We have used a class statement and then we have given a treatment, right? So instead of class, you can give by statement also. But when you are using by statement, you should have used first you have to sorted the data, okay, by site, and then you have to store the data. Now the site is arranged in the ascending order, site 1, site 2. There are, okay, site 2, site 3. Okay, now the data is arranged in the ascending order. Then you can use in proc team, you can in by statement, you can use site. So for each site, it will tell what is the average systolic blood pressure. Okay. So for site one, what is the average blood pressure? In site one, the average blood pressure is 135. Site two also the average blood pressure is 135. In site three, average blood pressure is 138. So in site three, the blood pressure is comparatively higher than site two and one. Okay. So you can use either class or by statement, but when you are using by statement, first you have to sort the data either in arranging order or descending order, and then you can use the proc mean. Okay. After that, you can use the by statement. Okay. This is little complex. So what I will do, okay. What we are doing is so if in proc means if you want to save the output, you can use output space out equal to whatever name you want, you can use it. Okay. So using output statement, you can save the data for proc means. Okay. So I have given output out equal to means out. You can go and check in work library. So in work library, my output will be stored. Okay. Means out. So so it will tell what is the average, minimum, maximum for weight and okay, systolic blood pressure. So using output out, you can save the data. You can store the data in library. After this and all, okay, not required. They don't use this one. Okay, yeah. So this is little important. Okay. So in pharma, there is in statistics there is one concept called confidence interval. Okay. So generally, confidence interval means uh, okay. So here for blood pressure, we are telling average blood pressure is 140, right? So this data is taken from some random number of participants. Okay. So you may know what is sample and what is population. Okay. Uh, okay. Sample means subset of population. Population, you know, what is the count of that entity? The okay. Sample means subset of population. Here we have taken some subset of population, 6 members, and then we are calculating average. Okay, so there is one way. So when you are saying 140 average blood pressure, this average is applicable only for 6 participants. Okay. But if you want to interpret for entire population in the world, then you have to use something called confidence interval. Okay. So in confidence interval means this is also similar to mean, but instead of interpreting to the sample, we will calculate the average value from sample and then we will interpret to population. Okay. So instead of 140, what we will say is 130 to 150. So we will say that there is 90 percentage confidence that our mean blood pressure is between 140 to 150. Okay. So instead of single value, we will interpret using two values. This is lower limit and this is upper limit. Okay. So confidence interval means we will measure it from the sample and then we will interpret to the entire population. Okay. So, if you want to calculate this confidence interval in clinical trial and all, the measures will be calculated from samples only 50 participants, 100 participants, not entire world, right? So, only they will take the samples randomly and then they will measure this confidence interval. Okay. For example, what is the average antibody concentration after the vaccine is given? Something like that. Okay, so if you want to calculate the confidence interval, you can give CLM here. Okay. Okay. Okay, so if you want to use confidence interval, CLM you can use. That means confidence interval. Alpha means I will tell what it is. If you are saying alpha equal to 0.05, then that means you are using 95 percentage confidence. Okay. If you are using alpha 10, then confidence is 90 percentage. You can say there is 90 percentage confidence. These values are reliable. Okay. Okay. So here, this is for weight. The lower limit for, so we have taken the data from 6 samples, and then we are saying the average weight lies between 66.9 to 89.6 with 95 percentage confidence. Okay. So we are saying 90 with 95 percentage confidence, the weight lies between 66.9 to 89.6. So if you are using alpha 10, then the confidence became 90. If you are using 20, subtract with 0.1, then it will become 80 percentage confidence. If you are using 50, then there will be 50 percentage confidence. Okay. Okay. So in statistics, there is something called standard error. Standard error is nothing but square of standard deviation. Okay. So standard error means standard deviation. If you calculate it for sample, we will call it as standard. But if you calculate it for some population, 1 minute. Okay. So if you calculate the standard deviation for sample, then okay, I will explain it in a clear way. Okay. So there is something called sample and population. Okay. Okay. If you calculate the standard deviation for sample, then we will call it as a standard error. Okay. If we calculate the spread or deviation in the population, then we will call it as standard deviation. Okay. Standard error means it is calculated from sample. Standard deviation means it is population. Okay. Just in a simple term, I am telling. Okay. So standard error is also one type of standard deviation. So if you want to calculate mean and standard error, you can use it as an option or yeah. There is some error. Okay. So mean is 78 and standard error is 4.4. Okay. Okay, this one is little complex. I will comment to later, or we this is we will cover it in a little advanced class. If you see this, it will say way two, but I will show you the output. What is that? So in class statement, if you use treatment, okay, and then sex, it will calculate the statistics for the weight and systolic blood pressure. Okay. Uh, okay. If you are using types, what it will do is uh, what it will do is it will calculate the tables, two tables. Okay. One is okay, one is treatment with sex. It will calculate the table. Another table is only treatment. Okay. So using this, you can categorize the data, treatment and sex together. Sorry. Okay. So one table treatment and sex, another table only treatment. Okay. So using that, you can calculate the systolic blood pressure and weight. Okay. So in class statement, you have to give both the variables. But in types, if you give treatment and sex, it will consider as a one table. And here, if you give treatment, it will calculate the table only for treatment. Okay. And there are two tables are there. So we are telling V is equal to 2. Okay. Okay. I'm sorry. So, so this is already we have seen by statement. Okay. Okay. So that is one option I told. If you want to save the proc means data, what you can do is you can give output out equal to whatever name. So the output will be stored in the by means. And then we are giving n means standard deviation, right? So three statistics will be calculated for this data. If you want to rename the variable n equal to slash n and mean equal to slash mean, standard deviation equal to standard, the output will be displayed in the okay. Right. Suppose if you don't use this, okay, okay, and then if you check in output, okay, so the okay, the n minimum standard deviation is there, right? So if you don't want to display this way, sorry. Okay. So what it will do is generally, okay, let me explain it in a clear way. So the code, what it will do is for each treatment, it will calculate the average weight, mean, and standard deviation. In output statement, if you want to rename the variable, what you can do is you can give like n equal to slash n. What it will do is this will rename this variable. Okay, but okay, yeah. Okay. Similarly, you can use multiple options like maximum decimal year and confidence interval year. Okay. Yeah. Okay. 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 So this is all about proc means. So whenever your data has some numerical data, if your data has some numerical variable, you can use the proc means. Okay. So proc means when your data have a numerical variable, you can use proc means. But what if your data has some categorical variable like this? Okay. Then you have to use procedure name called proc freq. Okay. Yeah. Okay. So when your data has some categorical, So I have some data. This is some the patient response. Okay. Uh, how well he responds to the treatment. Okay, here there are eight patient data. The first patient is from site one and he is a male and he has taken treatment A and he has got any adverse event. Yeah, he has got some adverse event. And what is the severity of the adverse event? Okay, and whether he is responding good to the treatment or whether he is responding poor to the treatment. Okay, so this is some patient response to the treatment. Okay. So we have data about the patient and what is the treatment they are getting and whether they got any adverse event severity. What is the adverse event severity? Okay. Let me run. Okay. So whether he got adverse event or not, adverse event severity scale, and whether he is responding well to the treatment. So here, if you see, we have lot of categorical variable. Treatment is one categorical variable. Adverse event is another categorical variable. Adverse event severity is another categorical variable. Responses. So sometimes our data will have some categorical variable. That time you have to use procedure name called proc treat. Okay. So, for example, in my data, I want to know how many participants received treatment A, how many participants have treatment B. Then I can use proc treat data equal to input data and tables equal to what is the variable name. I want to see how many participants has treatment A and how many participants treatment B. Okay, so treatment A, five patients are taking treatment A. Three participants are taking treatment B. Okay, the percentage is 62 percentage of participants are taking 62 percentage of participants taking treatment A, 37.5 percentage taking treatment B. Cumulative frequency 5 plus 3 8 it will come and this is cumulative percentage. Okay, so similarly, you can see whatever data you want. If you want to see the response, how many people has good response and how many people got poor response. So five people got good response, three people got poor response to treatment. Okay. So this is only for one table, one variable. I want to see in treatment A, how many male? In treatment B, how many female? Similarly, in treatment B, how many male subjects? And in treatment B, how many female subjects are there? If I want to check that, in table statement, you can give the two categorical variable. Okay, so first is treatment and then a sex, and then in between you use star symbol. So whenever you are giving two categorical variable, use star symbol here. Okay. So, as I mentioned, in treatment A, there are three female and two male. In treatment B, there are one male and one female and two male participants. Okay. So, if you want to see the count of the categorical variables, you can use this table statement. Okay. Now we are using three variables: treatment, sex, and adverse events. Okay. So in female, how many adverse event? No. So none of the female got adverse event and three female got adverse events. Okay. In male, one male got no adverse event and one male got adverse event. Okay. So like that, you can categorize the data and you can interpret from your. You can give three or four variables also here. Okay. And then, for example, you want to, we are uh, we are getting a table treatment and adverse event. How many in treatment A, how many got adverse event, how many didn't get adverse event. But I want to know how many rows and how many columns and no percent. Okay, so if you are saying no row, no column means it won't display the percentage and number of row and number of column, it won't display. Okay. So it will suppress unwanted percentage. It will simply display the count. Okay. If you don't give this, you will see lot of information there. So here you can see. Okay, so if you don't want to display percentage and cumulative frequency, cumulative percentage, you can use a option. Okay, there is an option. So if I say no cumulative, it won't calculate the cumulative frequency. Cumulative, yeah. Similarly, if I say no frequency, it won't display the frequency. Okay. 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 So this is one way. Another is if you want to display the data as a list, you can use after slash. You can say list instead of table. It will display it in a list order. Okay. So if you don't want to display the data in a table, you can use after slash. You can use list. Okay. So let me remove this. So here, if you see this table, first you are having a one row called table of treatment by AE, and then and then the adverse event column. After the treatment column, and inside we will have column. Okay. Suppose if I give slash test. Okay, the table will be in a very simple format instead of the grid formats. Okay, so whatever format option you want, you can use that option. This is okay. We have seen already this one. Okay, so there is one option if you can order the data. Okay. So it will arrange the data in ascending order. The first the treatment A will come and then the treatment B will come. Okay. Here there are only two options, but generally if you have more alphabets A, B, C, D, then it will sort the data in a order. Okay. If you give order by frequency, that means the based on the count. For example, whichever count is higher, it will display it here. Okay. For example, if no has the five frequency, it will display it four. Okay, it will display it first one. Okay, so whichever has more frequency, it will display it first when you are giving order equal to frequency. Okay, based on the frequency, since here both has same frequency, it is displaying no and then yes. But generally, if something has higher frequency, it has to be displayed first. Weight statement, we don't use much in the pharma companies. Okay. Okay. Yeah. Another important one is chi-square test. Okay. Chi-square test. Okay. Generally, chi-square means if it will tell whether any two variables has any relationship or not. Okay, relationship means whether this treatment is dependent on adverse event or not. Okay, so using the statistical variable, a statistical chi-square test, we can check whether these two variables are related or not, whether treatment has any effect on adverse event or not. Okay. So, using the chi-square test, we can check whether any treatment has any impact on adverse event. So, how to interpret this? There is something called okay, some there is some value called probability value. Okay, so when p this probability value is lesser than 0.05, then there is some relationship on adverse event and treatment. Okay, if it is greater than 0.05, we can conclude that the treatment doesn't have any impact on adverse event. Okay, so based on the p value, probability value, you can decide whether the treatment has any impact on adverse event or not. So sometimes we will have data lesser than 5. That time, what we have to use is you have to use something option called exact. Okay. So when your sample size is lesser than 5, you can use this test called exact. Okay. When you have a small samples. Uh, Okay, that option is not in the new SAS version, I guess. Okay, okay. Just remember chi-square test. So when you want to see two categorical variable, whether it has any relationship or not, you can use the chi-square test. Okay, whether smoking causes cancer, like that. If you have two categorical variable, then you can use the chi-square. Okay. Similarly, you can save the data, the proc freak output using after slash use out equal to AE freak. So your output will be stored in the name of AE freak. Okay, so this output will be stored in the name of AE freak. Okay. So similarly, if you don't want no observation, if you don't want to display the observation number, you can use no obs. Okay. Yeah. Okay, so in output, if you want to display the percentage, so we are storing the output in the name of treatment free, and then there you want to display only the percentage. then you can use out percentage. Okay, so what it will do, okay, so here it will display count percentage and all, but in output, okay, it's not available for one way table. Okay. Okay, so here if you see, we have given two-way table. One is treatment, in treatment, and adverse event. Okay, so the output of the procedure, it is displaying count, percentage. Okay, okay. I think this option is not working. Okay. Okay. So this out percentage, it's not working. But generally, if you want to store the output of the proc freak, you can use out equal to freak. Okay. So okay, and then okay. So similarly, if you want to know what is cumulative column, cumulative row, cumulative frequency, you can use the option here. Okay. Like cumulative column. So if you don't understand what is cumulative column, it will you can see it in the description here. It is telling it display the cumulative column percentage in the cells of the cross tabulation table. Okay. Okay. So cumulative percentage is nothing but first percentage is 62 and then 37.50. If you add together, it will come it as 100. Okay. So it's simply the addition of percentage, similar like cumulative frequency. Okay. Format, we will take it as a separate one. Okay. 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 I think we have covered most of the things proc trees. Already time is crossed. Okay. So the main thing you have to remember is the three thing. One is if you can using proc freak, you can create a tables which says the what is the count of the each categories. And similarly for two-way tables also in you can create two-way tables also, and you can give multiple variables in treatment statement similar, and then you can another important thing is the chi-square test. So if you want to see the association or relationship between the variables, you can use the chi-square test. Okay, if you want to see whether any treatment has any impact or association with adverse event, you can use chi-square test, and using p-value, you can check where you can interpret the variables. Okay, these three things you have to remember. Okay, I will give one assignment for Proc Means and Proc Freak. Okay, and then after that we will have only two classes. One is for Proc Report, another is for SAS Date. Okay, yeah, yeah, these two things we will complete, and then we will wrap the basic session, and then we will go to advanced SAS, advanced clinical SAS classes. If you have enrolled, you will be eligible to attend that classes. Okay. Yes, you can do ANOVA. Yes, very good point. That will be little advanced. Okay. Anyway, there is something called proc ANOVA. Okay. There is one procedure called proc ANOVA. Okay. So using this proc ANOVA, data equal to uh, okay, and then you have to give model dependent variable I'm giving. Okay, and then on okay class A. Okay. Okay, 1 minute. Okay, sorry. In class treatment will come. Okay. I will explain what is class and what is dependent. Okay. Let me give cholesterol. Okay. So what we are okay. Oh, okay. Uh, okay. So in class, I'm giving site, and then in model, I'm giving cholesterol. Okay. Uh, One more. Okay, so there is some syntax error, but this is the code. So using ANOVA, what you can do is, if you want to compare three averages, for example, we have one data. Okay, so example, we have treatment A, B, C. Okay, so we have three treatments, and I want to check what is the average of treatment A, what is the average of treatment B, and what is the average of treatment C. So you want to compare three treatment and you want to know which treatment is better than another treatment. Okay, so you want to check which treatment is better than another treatment. Okay, so that time, if you want to compare three averages, treatment A, three treatment B, you can use the test called ANOVA. Okay. So we have seen one test called chi-square test, right? Chi-square test is for categorical variable. Okay. If you want to compare two categorical variable, you can use the chi-square. But if you want to compare more than two averages, okay, then you can use proc ANOVA. Pooja, you have asked the ANOVA code, right? I will send the ANOVA code. Sorry, my internet got disconnected. But I will say, Pooja, I will send you the ANOVA code separately to you. Okay. But that are all little advanced statistical terms. We will cover it in advanced SAS also. But if you are really interested, I will send some materials to you for Prof. ANOVA. Okay. There are for proc and and it's a test we can do. We can do T test in SAS, and so many advanced tests we can do it. Okay. Okay. So if you have any questions, let me know. Otherwise, we will wrap this session for now. Okay, I will take it as a no. Okay, thanks everyone for your time. We will see next week. I will give one assignment for proc means and proc frequency. Uh, okay, okay, thank you everyone.